my name is Maggie Anderson. I'm a senior at the University of the Cumberlands, and I'm here today to talk to you about my research project, an examination of nest predation of prairie warblers on a reclaimed surface mine in Kentucky. North American wild bird populations have declined by almost 30% since 1970. The encroachment of industrialization, farming, urbanization, and active mining has led to a decline in the shrub nesting population especially. Predation accounts for most of the nest failure of shrub nesting birds, and reclaimed surface mines may be a good habitat for shrub nesting birds to grow back some of their populations. In 2000, which is the last published census of the mines in Kentucky, there were 240 active surface mines in Kentucky, which means that there is a lot of potential for habitat for these birds to grow back into. Our main subject was the prairie warbler, and this is a picture of two males. They were our main topic because they are listed as a species of most importance by the Kentucky Department of Fish and Wildlife. This is because their populations are declining, and we want to make sure that we keep an eye on them. The goal of this project was to study the nesting success of prairie warblers on reclaimed surface mines. In order to achieve this goal, our objectives were to document the survivorship of prairie warblers on reclaimed mine land, describe the suite of nest predators, document the time predation events occurred, determine what stage the nest is in when predation occurs, document if nests are more susceptible to full or partial predation, and describe the microhabitat of the nest placement. We also opportunistically collected data on some other shrub nesting species during our study. We believe that due to the successional condition of our study area that we will see high levels of predation and nest failure, and this is based upon a study in our literature review that we found that nests that were in shrubs were more likely to be predated than nests that were on the ground or in forested areas. Here's a picture of our study site, and we were in all of those open areas that you see on there. It is owned by University of the Cumberlands. It's about 8,000 acres total, but we were focused in those areas of open field because that's where our birds would nest. We found nests by making behavioral observations of adults and by conducting grid searches over potential territories. Cameras were placed on active nests. From pictures, we determined the cause of failure for all of our failed nests, and we were able to determine the date of fledging if the nests were able to survive. We used the Mayfield estimate to calculate the probability of nest survival, and once the nesting cycle was complete at each nest, the vegetation composition was measured like described in the Breeding Biology Research and Monitoring Database Protocol. Here are some pictures of our camera setup, so you can see that if anything natural was around for us to strap the cameras to, we would preferentially select natural things, but if not, we would use fence posts, and if nests were too tall for fence posts, then we did use an extension pole that was wedged in between two fence posts for stability. And the picture on the bottom left shows us checking a nest that was up high with an extension pole with a camera attached to it to see if there were any eggs or nestlings in that nest. Here are some pictures of our prairie warbler nests. The one on the left shows baby birds that had just been hatched either that day or the day before, and the one on the right shows two that were about to fledge and leave the nest. We monitored 12 prairie warbler nests. 3 of them were successful and fledged young. 9 of them failed. 2 failed due to abandonment. 7 failed due to predation, and 1 of those abandoned nests did get predated after abandonment. Predation consisted of 1 snake, 2 birds, 2 mice, and 3 predators that we were not able to catch due to camera malfunctions. Prairie warblers were the only species with a sample size large enough to run the Mayfield estimate. With a 23-day incubation period, the estimate gave a 27% chance of them fledging at least 1 young. We monitored 2 white-eyed vireo nests. 1 of the nests was successful and fledged young. 1 was predated before we could get a camera on the nest, so we don't know the predator. We observed 3 yellow-breasted chat nests. None of them were successful and all failed due to predation. The predators were one snake, one mouse, and again we had one nest that did not have a camera on it, and so we don't know the predator. We observed 3 indigo bunting nests. 1 of the nests was successful, 2 failed due to predation, and the predation consisted of 1 mouse and 1 snake. Our prairie warbler nests were between 0 and 4.84 meters, and the average nest height was 1.74 meters. And honeysuckle, various species of it, were the most common plant for nest placement. Here's a picture of an indigo bunting nest that is being predated by a snake, and this nest was in the nestling stage, as you can see by the picture. This picture shows an indigo bunting was being predated by a mouse. This is a picture of a crow, and this nest actually had 4 prairie warbler nestlings and 1 cowbird nestling, and the crow was so big it couldn't fit into the image. And this nest was actually predated first by a blue jay and then by a mouse. This was the last nest we found. And here's a picture of a mouse that was using a previously predated nest as its own nest, and we saw this happen actually quite a bit out in the field. These results indicate that on a reclaimed surface mine, predation is the most frequent reason for nest failure in prairie warblers and in other shrub nesting birds. It's also worth noting that most snake predation occurred during the egg stage, while the majority of mouse and all of the bird predation occurred during the nestling stage. And nearly all nests that were in honeysuckle failed. So for future research, we do need to conduct this study over multiple years because our sample size was low to create any real observations from it. We would need a bigger sample size over a few years. But other than that, do honeysuckles create an ecological trap for shrub nesting birds, making them think it's a good environment to nest in when in fact it's only setting them up for predation? And how do snakes detect nests during the egg stage? And I would like to thank the Appalachian College Association, the Kentucky Society of Natural History, and the Kentucky Ornithological Society for funding this research. I would like to thank the University of the Cumberlands for allowing us to use our study site. And I would like to thank Dr. Sarah Ash, Dr. Brett Coos, and Dr. Renee Yetter for helping me out with this project. And if anyone has any questions over my research, you can reach me at the email address below.